Yesterday, the first presentation was given in the axiomatic basis, transferring the linear number 1 to the circle. Just to remind you, the circle is the closed line. The traditional straight line is a very special case of the family of lines, and it's magical and miraculous that the straight line, the most peculiar of all the lines, contains the number system that's given us the ability to get into outer space and to harness electricity. The sine wave is a linearized circle. What I want you to see are the 3 arrows pointing sideways, each of which says wavelength. Each arrow is the same length as the circle has been stretched. And that's in order to bring out the temporal aspect of the circle. This is unique to the circle. The line has no temporal aspect. There's no such thing as a repetition on a line. But on a circle, everything is repetition because it's closed. It has no beginning and end, and therefore any motion function is not linear. It's repetitive, and the repetitive action introduces a new data type. It is possible to exchange the irrational portion of the relationship with the linear, actually a counting number. The number for unity, the simplest of all the linear numbers, is 1. We put that on the radius in order to introduce number system into circular space, and the result of that is the irrational number tau, equal to 2 pi, almost universally still written as 2 pi. There's nothing wrong with that. Here we will prefer the symbol tau, because that is an invented symbol, actually invented in the 21st century, around which was created quite a hullabaloo earlier this millennium, but without too much effect except to educate the public to the distinct option to change our convention from 2 pi to tau. And there was quite a cult uprising. It didn't get too far, but that's understandable. There's nothing wrong with 2 pi, but here, actually, we will prefer tau. Circumference equals tau r. So instead of the circumference equaling a multiplication, the radius is equal to a division. And this is called inversion. And that is the value of having 1 on the circumference. This will be the frequency-wavelength relationship. The frequency-wavelength relationship became extraordinarily famous because of its utter simplicity. What I'd like you to notice here is what's called the inscribed polygon of a circle. Inscribed means inside, called a polygon, the smallest one of which is the triangle. But to draw an inscribed polygon on a circle is actually quite a challenge for each one of the polygons. It has been shown up to polygon 17, I could say the name, but it's not necessary. It's a 17-sided polygon. A very famous mathematician figured out how to construct exactly a 17-gon. And I'll leave it to you as homework if you're interested to look up the name of that extraordinarily famous mathematician who figured out the inscribed 17-gon. Now, why am I showing this to you? You'll notice that the triangle makes 3 points on the circle. The square makes 4, and any school child is aware that this forms an infinite progression that is a very interesting introduction to the calculus, because the Greeks actually tried to use this method to compute exactly the value of pi. And this is a method that has a famous name now. There is one more polygon that we do not call a polygon because it doesn't have an interior. It can be shown that the smallest figure, that is the smallest number of straight line segments that can be used to enclose an area space, is 3 lines. But the circle does have room for one more figure. Having 2 points on the circle is a diameter, and the 2 points making the endpoints of the diameter are the dihedron. It's actually a polygonal figure called a dihedron, And it's obviously peculiar because it has no interior. It's actually just a straight line. So, but it does make 2 points on the circle. So polygonal figures are all inscribable on the inside of a circle. I want you to see what frequency is. This shows before the start of a 1-second test. Look at the top diagram, and what it's showing you is a static portrait of the waveform so that you will see its length. This one is given as 5 meters, which would be quite a long wavelength. I believe that's in the radio frequency, but whatever it is, it's a valid wavelength, but it's a long one. Wavelengths are a measure of linear distance, but it's interesting that that's not exactly true. It's computed as a linear number. That is what a length is. It's a linear number. However, what is it actually measuring? Well, the wavelength in this top diagram is fixed at 5 meters, so that's good. We know its length. And you can see that it shows you with the red arrow that that is the wavelength. It's measured from crest to crest. But as you noticed from our first diagram, which I believe we still have here, there it is, all 3 of those wavelengths, even though they're not from crest to crest, the next one down is median to median, and the bottom one is the trough to trough. But they're all the same length. So this is constant. The wavelength is constant. Now you knew that, but here's what I want you to see. Consider wavelength 3 and look at that triangle and consider the arc segments that are cut off by the triangular points. That would be wavelength 3. Now, it's not said that way because you can see it has to be a fraction less than 1. Consider that verbatim, that the wavelength must be a fraction of 1. The wavelength is not 3. That's the frequency. The frequency is 3. The frequency is the number of points on the circle. The wavelength is the wavelength of that frequency, and that remains constant. In the drawing of inscribed polygons in a circle, it produces the wavelength-frequency relationship on a closed line. Consider this question. What is the lowest frequency? Do you know? I think you can guess. It's frequency 2, isn't it? Yes, the lowest frequency in the universe has to be the whole number 2, which is a remarkable discovery that was made by Max Planck. It is considered to be the discovery of the quantum. Now, frequency 2 is not one of those polygons, but it is the special polygon called the dihedron. So that's included in the polygons. The way nature has composed the wavelength frequency, frequency 2 can be drawn as an inscribed polygon. And that is the simple oscillator, the simple harmonic, the simplest mechanical form of energy expressible in mathematics. It's a frequency wavelength relationship, and that is a relationship between 2 data types. That has not been fully comprehended geometrically, but you and I can see it on the circle, that the frequency for any light, this perfectly describes the geometry of light. Light is exactly described on a circle. Exactly described. So this shows frequency 3, frequency 4, and frequency 5. It forces us to take Albert Einstein seriously. Wavelength times frequency equals C. 1 to 3, 3 parts in 1. That's the wavelength. The frequency is the number of points. That's a whole number. These two numbers are reciprocal. And when multiplied together, reciprocal numbers always equal 1. That is the same number 1 that you see here, and pardon the pun on C, but when you see C, C is 1. When you see C, C is 1. So C is 1, and lambda and nu are the two reciprocal numbers that make 1. Therefore, the circle represents light speed. The number 1 that we've put on the circle is the number for light speed. It is the number 1. The relationship between distance and time in the unit number we call light speed, which is commonly unitized to 1. So it is always possible to unitize any of the units used in mathematics. 3.0 times 10 to the 8th, if you want to be more exact, it's 2.99. If you want to be more exact yet, you can get the exact number, which has been fixed for all eternity. It doesn't matter if we're off by a fraction of a meter, because it actually is the most precise two-component number ever revealed in physics. So it's remarkable that Max Planck uncovered the fact that the universe uses our linear number system in a two-component number system. The universe does. The universe uses whole counting numbers only in these proportions. Now, the Greeks intuited that, but once they encountered irrationality, they really didn't know what to do, and really nobody's known what to do since. The current solution for the irrationality that exists in curve measurements, particularly circular measurements, are forever imprecise, but they don't have to be because we can unitize the circle. It's 2 in proportion to 1, and 1 in proportion to 2 at the same time. So that means, strictly speaking, 2 data types. There are 2 data types. We're only familiar with 1 data type, but Albert Einstein has already informed us you actually need 2 data types. Well, we never obeyed Albert. We never followed up on what Albert proved. We never discovered the second data type. The second data type that we use is called time, because time is the component in the speed of light that is so mysterious. That what is a second? Well, you could say, first of all, that the second is an arbitrary time length. We always say length, and that's because we experience time linearly. Is a linear progression of events. We presume. Now, Einstein proved that that is not precisely the case. It's actually a correlation between time and space. And he did succeed in proving that, so there is a relationship between time and space. Well, we see it in light speed. It's a direct proportion between time and space. For every unit of time, there is a fixed distance. That actually is the definition of relativity. It seems obvious to us now because we know that Einstein computed the relationship, but he did so in spherical space. And that was probably the most difficult mental computation that any human has ever formulated, before or since, was Einstein's perception of the linearizability of time. I'm now going to reveal to you both the strength of Einstein's discovery and its inevitable failing, which may come as a shock to space-time lovers, even the Nobel Prize laureate, which I have to laugh because he wrote a 150-page love poem. It was almost sickening. Well, it was sickening. I have his book, but I've only read a fraction of it because it's like a juvenile girl's diary. I don't like it when our scientists do this, because it's not just that it's demeaning. It's that it's foolish to give such praise to a simple mathematical construction. It ultimately is that simple, that it's a relationship between spatial distance computation and the time lag involved. That's why we have space travel, is because you actually need to do that. So he did execute an incredible discovery that has been implemented very successfully. Space-time is extraordinarily successful. Well, it represents something that's physically untrue. It shows that there is a direct linear correlation between space and time. You could say that, and it seems tautological, that for every spatial separation, there's an exactly equivalent event separation. That a light year, by definition, is both a time and a space measurement. You've measured a distance of a light year, however you did it. It has been done, but you can imagine this took a while to be sure that we know what we're doing. And there's a good YouTube presentation by Veritasium on the fact that we cannot measure light ever in one direction. We can only measure light when it's been reflected from a source. And the reason for that is well worth knowing, but I won't go into it here. Consider that to be either a prize or homework, however you look at it. But light speed is two measurements. You have to make two measurements. One of them is the distance. But once you have the distance, you have to take a second measurement, knowing what the distance is because you've already measured the distance. You can see a kind of a catch-22 in there. Because in order to measure that distance, you have to have a distance separation, which entails an event separation. So you have to already compute the time lag in order to compute the time lag. Well, that's rather difficult, I'd have to say offhand. Oh, well, it's been done, though. Although the tests continue, because it's very important to be sure about this. But the problem that's come up, it has come up in quantum mechanics. That actually there's a glitch in that interpretation, because we've discovered direct evidence that's only recently been absolutely proved that Einstein actually was right in condemning his own space-time system. Whether directly or indirectly, Einstein's insistence on the hidden variables interpretation of quantum mechanics, which was defeated, he was actually considered to be wrong. And it's considered now that Einstein was proved wrong. But by proving him wrong in the Bohr-Einstein debate, it actually proves that space-time is consistent, which is untrue. Actually, the quantum mechanical paradox does not exactly disprove space-time construction. What it does is it forces a reinterpretation of Einstein's solution because it's the wrong geometry. I believe that's got to be one of the most remarkable facts to be proved. I insist that I have proved it, and that's what you're going to be learning. But this is the starting point for seeing that the problem we're having between space-time and quantum mechanics has to do with the geometry of the circle, that it's not being seen or used. And the first insight, and this is what I want you to take away from this, is that frequency is not measured in the same units as wavelength. And that's never been understood, that that is actually a different data type of the universe. So the question is, what are the two data types? And that's what we'll be exploring in the next presentation. But if you're clever, you may have already noticed what the difference is. We're homing in on time, what it actually is, which has never been understood. Well, that's quite obvious, that nobody knows the cause of time. At least I've never heard it stated. But the only way to actually see what causes time is in circular geometry. It's literally impossible to see any other way. And that's because of the unique nature of the closed line, that it's continuous. It can be proved that the straight line cannot be continuous, because the only way to use it correctly as an object in this universe is to linearize it with numbers. So the straight line is absolutely useless for any other purpose in the universe except to generate quanta. And this is the origin of the concept of the quantum. It comes directly from our perception of straight line geometry, that on the circle, there is no such thing as a one-component quantum. And Max Planck discovered that as well. He didn't say that he discovered these things. I'm saying he discovered these things. He discovered the lowest counting number that the universe uses. It's a split number too. That's been proved. So we know the number system that the universe uses. I've proved that that number system is the circular number system. That, of course, is a major insight. So that's what you're going to be learning, and thank you for tuning in. We'll be back very shortly with another lecture in the Unimetrics series. And here I just want to make an apology, because I've noticed it twice. Once in writing in a description, and once verbally. I called this the Univex series. Univex. That's another term that I invented. Unimetrics is the geometrical mathematical system, and that's the word that I should be using. But Univex is a bona fide word that I invented for science. It refers to what had to happen geometrically in order for there to be a Big Bang. The Big Bang has not been disproved fully, because it's impossible to disprove it fully. And so we're going to maintain the perception in consonance with consensual science that it is a viable option, at least, to consider that there was a Big Bang. There was something like it. And there's no question now that the plasma physicists are excited for a reason. There's a reason these quantum mechanists are going out of their gourds, talking about the first milliseconds of the universe in a vast explosion. It's because they're concentrating on an aspect of the universe that needs to be studied. It's rather, I would have to say, a bit precipitous to drill into children's heads that the universe had to begin with a Big Bang. I'll always be against that, because that is, of course, anti-science. You cannot brainwash the children just to make slaves for your goddamned industrial system for the government. Force them into calculus to make monkeys out of them so you can fill your fucking Godfather's rice bowl, you assholes. Don't you ever mislead children with that shit. I will. All right, stay tuned. This is Anagalactic. We'll be right back, and don't forget to keep looking up. And I hope you tune in. It's going to get pretty good. I hope you've enjoyed it so far, but I told you, and I'm sorry, but I have to say this. It's slow at first. This has always been the case, so I'm not the first person to have to apologize. for being a little bit boring, tedious, and maybe clumsy at first. But I guarantee you, things are going to pick up very, very